happens is basically the stream is now live. Okay, fine. So if I want to like share the link, this is the stream link, and this is the stream key. So if you just go to your OBS here, you will go to settings and just put the stream key there. Whatever. That's a discussion for a different class. But today, what we are going to be focusing on how to understand networking in Linux. Okay. And this is a chapter which will be covered in your CBSC class 12, and also like it's a very crucial chapter in the sense that you need to understand a lot of things. But first, I want you guys to use a few AI tools in your daily work life. Okay, ये तो चलेगा, right? ये तो चलेगा. So here, one of the tool is this Notebook LLM. What you shall be doing? Just go on to Google, search Notebook LLM. So it will come as notebooklm.google, and then just click on try. Why I am saying this? Because today I am using this to go into this like understanding of how networking and everything is working. Okay, and we shall be doing a few practical runs as well, like as much as I can. That's the thing, as much as I can. So first thing, before we go into this, like start by going through each and every topic, I just have a simple question. How much of networking have you seen in your, let's say, life till now? Let's start with Niket. Like, have you used any networking tools?
No.
No. Okay. So suppose I want to give you a very simple, let's say, outlook. Let's think. Do you know what ping means?
No.
Niket, you play games, right? So, like, don't you see that there is something called the ping is high, the ping is low? Gamers are always saying.
It indicates the speed of the network.
Not exactly the. Okay, it's more like that. Each transaction is happening at a fast pace. So, suppose your network you are having.
There is an also an ping section.
Hmm. Yeah. Huh? I think that's not the account. It's Think-SBS-Think. So yeah, that's my room. But you were saying something. So ping, you will see that the gamers are saying that ping. Yeah, Niket, what you said is kind of related. But understand that I may have a very high speed network. If I do a speed test, okay, speed. So I can have a speed test that I'm doing here. Okay, my speed might not be that good, but whatever. So this thing is checking the bandwidth of the network, means how much of data at a moment can be transferred through your network pipeline. Okay. Whereas ping basically says that how fast your transactions between your client and the server is happening on the same network. Okay. So I'm doing a few comments here. So let's say we are
What do
going
you
to
mean
ping.
network pipelines?
Huh? Uh,
What do you mean by network pipelines?
Okay, network pipelines. Good point. Network, let's say it's not pipelines. It's pipeline is a general term that we use to define how a whole structure is set up. Okay, like you have seen pipelines in your plumbing, right? In your house, you will find that this your water
Yeah.
faucet is connected to your tank in some way, like so that the tank is high up in your house, right? At the roof, you have the water tank. And because why do you have it? Because it will store potential energy so that water can easily flow downside and reach
That
each
is
and
fluid
every.
dynamics. No, you are teaching fluid dynamics.
Fluid dynamics. Okay. Not dynamics. It's still not dynamics unless until we talk about the flow, but whatever. So
Yeah.
what happens in a pipeline? You have something which has some high potential, something which has low potential. In networking, you also have nodes. Okay, nodes which are of different importance. So importance means suppose you have a server. So server is a node that everyone wants to connect to. Say Google. Okay, everyone wants to do a Google search. Okay, and understand that in that Google search, we are the clients, we are reaching out to Google. So probably we are sometimes flowing against the current or something like that, but that's not a good analogy to say right now. But basically means that there is an internal structure that is there which helps you connect to a like server on the internet. Understand that you are here in Kolkata, trying to get to Google server. Some of them may be located in America, some Berlin, or maybe in India. I think there are in Maharashtra and other places. Probably two or three are there. But the point is that you are sitting here in Kolkata and pinging to servers, or let's say, connecting to servers which are located very very far away. Okay, how do you do that? You basically do that by packages of data or data packets. Okay, being transferred from your own device through a network. That means it hops from one node to another. Okay, basically from here it goes to the nearest like towers. Then again the towers redirect your packages to another tower and all this. Okay, this is what is happening. Basically you send a letter. Okay, suppose you want to send a letter to your crush. Okay, and what happens, you don't
It is sometimes
exactly,
a query, right?
it sometimes
It's some type of a query we send, right?
query resending. Uh, may you please repeat? I couldn't get it.
It is a query we send to the local network and that redirects to the main server, right? Not
Yes,
node. It's a
and
query
yes,
something, right?
it's you are sending a query. That is correct. But the query that
Yes,
you are
that's it.
sending, the query that you are sending, it is getting redirected again and again till it reaches the server, and from the server also it gets redirected again and again, or rerouted
How many
based on
times it get redirected?
wo hopping and all this. We are going to be discussing because that's a path that will follow. So don't worry. So here I'm going to ping this server, that is google.com. Okay, as you can see, I am sending 64 bytes packages. Okay, and yeah, this is probably the IP, and it should not be okay. I should not be disclosing my IP at this point. I do need to stop it. Okay, and as you can see, it was able to do this like these many packages. Okay, and there is 0% loss, so it's good. Okay, fine. ये तक चलेगा, कोई प्रॉब्लम नहीं है.
No, no.
Okay, now let's go here. So what do we have? We have
How did you
the,
get this type of illustrations?
oh, that's a good point. So I have this whole document. Okay, this is the document here, and this is notebook LLM. Here, if you just put the document and then ask for it to give me a mind map. Okay, it gives you a mind map of the topics that we are going to be covering. So first topic would be basic
You can do it to
introduction. Yeah.
chat GPT and DeepSeek also. Why are you using notebook LLM? Is what we
Yeah.
are.
Mm, understand that the ChatGPT and DeepSeek has a context length limit, and that limit is around probably 32,000 or maybe 120. I forgot what's the context length of DeepSeek. I can just search it. What's the context length of DeepSeek? So it's about, yeah, 128,000 tokens. Okay, but what happens in Google? Google has a context length of a million. Do you understand that a million is like so much?
10 lakhs.
Yeah, a million means 10 lakh, that's fine. But the thing is that it's able to take information of, let's say, 10 lakh words. Okay, it's not exactly words. Tokens are not equal to words, but kind of equal. Okay, kind of equal means average out to those, you can
The
say.
spaces also include the tokens, right?
Hmm?
The token also includes the space, right?
It sometimes actually includes a space. It
The
sometimes includes
spaces
a
between the two
part.
words.
No, it also sometimes includes the part of the next word as well. Okay, so how to make tokens and everything? If we are going to get into, let's say, information retrieval or any other like that part of the course, we shall discuss. But currently, it's not the time. Sorry. Okay, so now understand that we are going to be discussing first part here. Okay, which is basically, let's go to our diagram real quick. First is underpins modern existence and all this we already know. So I'm going to go, the data and the files will be shared to you. Okay. Currently in introduction, I just gave you like how in a modern life we are actually using these networks, right? Just you are connecting to server and all this. Now, this currently has not that much importance in our current discussion right now. First, let's just go to our IP addresses. Okay. So what are IP addresses? We can discuss about that right now. So as you can see, I'm literally using AI to like generate the class notes or the stuff that we are going to be discussing here. Okay. So these are first of all, what does IP even stands for? It's Internet Protocol. I don't know why um, it never went into discussing the full form of IP. So IP generally stands for Internet Protocol. Now the question is, what is a protocol? Understand a protocol is like a language, okay, or like a language barrier, you can say. But currently I'm communicating with you two here through a medium which is an English language, right? So that is a protocol that I am following, that is a law or a rule that I am following. To communicate with you, I need to speak English. But suppose I want to communicate with someone from from Japan or maybe from China who currently doesn't know English. So then I have to communicate with them through Japanese or Nihongo or Mandarin or Cantonese for a Chinese individual. Okay. Now understand that that kind of change of language means a change of rules. Okay. But the data that I want to transmit or the feelings or the whatever I wanted to convey remains the same, but the method of conveying that information has changed. So that is what we call as protocol. Okay. Now, IP basically means the Internet Protocol, the protocols that are followed by the network packages to get to their addresses. So IP addresses basically mean on a network what could be the address. Okay. So now understand that in that IP address yeah, it's fine. So for a device to communicate on the network, it must have a unique identifier, which is an IP address. Okay. So everyone should have a unique IP address in their own network. Okay. And there are two types of IP addresses. Um, One is the IPv4 and the other is IPv6. Don't ask me where is IPv5 because that just goes into the territory of history and storytelling. We can do that later. Okay. So, Dutika, currently, up till now, do you have any questions? Were you guys able, all of you, were you guys able to understand um, what do we mean by protocol and all this?
Yeah, yeah.
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 Okay, good. So, from here, we are going to be moving onwards to understand why do we need so many different versions of IP address. And this part is a very important question in terms of like sometimes they ask in your practical or sometimes the teachers are just making fun of students or sometimes they ask it that why do we have IPv4 and IPv6? And the very simple answer would be we currently the world's population is growing, right? So number of devices are also getting like people who are using number of devices. Like I am using my laptop, I'm using my phone, I'm using my tablet, and I'm also having a headphones and all this whatever. And if your headphones are like what they call smartwatches are also connected to a network, they also need a address, okay, of themselves to convey the information to the internet and stuff. So a single person can have let's say 4 or 5 devices which are connected to the internet, and I don't know currently how many people are actually on the internet. How many people are on the internet? It's 5.5 billion currently to this Statista. Okay, some website. So currently 5.5 billion people are there on the internet. Okay, and let's say each one is having let's say two. Let's say for a simplistic average house sequence, let's say everyone is having two. Some may have one, some may have four, some may have three. Let's say two or two related. Okay? So there are 11 billion devices or probably 11 billion IP addresses which might be unique. Okay. And understand that in internet, if you want to send a packet, you want to send it only to someone, right? Suppose you are sending a letter to your crush. You don't want that letter to fall into the hands of your father. Do you want that? Probably not, right? So everyone must have a unique address so that we can send specific data packets to the specific person. So how many devices? How many devices can we have on IPv4? So if you just see, it is currently 4.29 billion. And how do you get it? Because it uses a 32-bit unique addressing. So how do you get the 32-bit unique
4,000
address?
combinations each bit.
Yeah, it's basically a permutation combination. That's true. And how do you get to that 32 bits? So understand this. This is 162. Okay, this is 168, and then this is 1 and 1. So this is these are numbers which are currently like 128-bit numbers. Okay, no, this is one not 120. This is 32 bit. Sorry, it uses 32-bit numericals, as you can see here. So I can have a range that will rise from, if it's 32, that will be 0, starting from 0 to 255. So at most I can have the address 255.255.255.255. Okay, that's the max address that I can have starting from
Please
0
repeat
dot
this
0
thing.
dot.
Please repeat this thing.
Yeah, so understand that what's the maximum range of addresses that I can have. It will be 4 sections. Okay, so it is 0.0.0.0. There are 4 different sections in a IPv4 addressing. Okay, let's see. Give me a second. Let's go here, and if I just go
Decimal is the how many bits? Decimal system.
here, decimal system is decimal means what? The base system is base 10, right? It's not about bits there.
Yeah.
Unless until you are literally calculating the
So,
entropy of that
so
system
how
and
do you
stuff.
define the 32 bits?
हाँ, दिखाओ, अभी देखो इधर। ये देखो 192 जो है, how do you represent the 192? You have to represent it in 8 bits. Okay, so 8 plus 8 plus
Oh,
8 plus
octadecimal,
8.
octadecimal.
So huh?
It is octadecimal, right?
No, it is
Class
not.
11's first chapter 9, number system, decimal system,
No, no.
hexadecimal system, the
Okay, okay,
formula.
okay. You are confusing in a different way. Let me clarify. Just give me a second. So understand what happens in an octadecimal system. In octadecimal system, you basically have a limit of representation of numericals or numbers till you have, by using only 7 different so not 7, sorry, 8 different symbols. So let's say I can have alpha, beta, gamma, delta, phi, psi, okay, and I can have 8 different characters representing different numbers or concepts of numbers. Say alpha means 1, beta means 2, gamma means 3, delta means 4. Okay, in this way, okay, we need to start with 0. So let's say phi
So
means
is this
0.
one double one? How after the zero? This is the conversion of 192 into octadecimal.
No, no, this is the conversion of 192 to like binary, base 2 system. Okay, so
Base two
understand,
system.
understand.
Why it's 8 bits? Oh,
Um,
okay, tell me.
Alright, base 2 na, you just go here. If you, okay, is my cursor visible?
Yeah, yeah.
Okay, so understand that this is the first bit. Okay, that means 2 to the power 0. 2 to the power 0 means it's 1. So it can have a value of 0 or 1 times 1. And here also it can have a value of 0 or 1. This is 2 to the power 1. So this is the first index. That means this is the 0th index. This is the first index. So it can have 2 to the power what 1 times 0, that is like that is the give total value, and the index is 2 to the power 1, that's 2. Okay, so then it is 4, then this is 8, then this is 16, then this is 32, then this is 64, and then it is 128. Okay, so understand 8 bits means you have total how many combinations possible? It is 2 to the power 8. And what is 2 to the power 8? 2 to the power 8?
Papiency.
Using?
Using PNC actually in that value.
Hmm. Of course, we are using permutation and combination. That's it. So, in this particular sequence, what is the maximum range that you can have from 0? What should be the ending range? Yutika, would you like to try the question? What is the maximum limit of numbers or total number of unique numbers that you can represent using 8-bit system? Like not a 8-bit binary system.
2 to the power 8 is 256.
Yes, and you need to have one less because you also need to represent 0. So it is 255. Okay, 0 to 255 you can do, and total combinations or total numbers that we can represent is 256. You're absolutely correct. So understand that in this whole segment, in this like ये देखो ये क्या है 192 है, you can see this. So this whole segment, this is one segment, this is another segment. Okay, so I was using the screenshot tool to say, but then this is the second segment, this is the third segment, this is the fourth segment. In a
Why there are only four
IPv4,
segments?
yeah, in IPv4 addressing, there are 4 segments. Each segment is represented or can have at most of 8 bits, where each bit represents 2 different binary states. Is that clear?
Yes, yes.
Very good. So at most I can have 2 to
So,
the
so we can
power.
use
Uh,
more
yeah,
number of bits, so we can
very
have
good.
more range of values.
Yes, yes, that's what they did now. That's why we have
Why are we not
IPv6.
using 32 bits?
Okay,
No,
that's
I
the
mean, why are we not
the
using hexadecimal 16 bits? Why are we using 8 bits? They're giving more range of numbers, right?
yeah. So what happens? So suppose you want to develop a system, your own Python code, and you are starting with, let's say, integers. Okay, then you realize, okay, you are making a banking system. Then you said, okay, integers का range बहुत है, चलो integers use कर लेते हैं. Python में बंद करते हैं, चलो C में करते हैं, because Python has this weird way of representing integers which is different from C or any other language, whatever. So let's talk about C. Okay, a little bit C. So in C programming language, there is a limit of how much what do you call this? How many combinations, let's say how many numbers you can store using an integer. Okay, it is basically a 4-byte system, so 2 to the power 4 into 8, whatever it be the number. Okay, so that's the limit. You can't represent anymore. But suppose now in a banking system, what happened that you started giving interest, and interest means some percentages, and that percentage is now fell into like point. Let's say I give you some person, and now you after interest you should have something like, let's say instead you had 100, now you are getting something like 7.5%. Now you have 107.5, but it was initially integer system. So currently you can't represent that 0.5. So if someone rounds off it to either 107, then the customer will say, hey, मेरा तो 107.5 था, right? And then if you round up to 108, then it is your loss as a bank owner. So what's the best thing? You need to use higher precision. Higher precision means you switch your system from your integer driven system to a float or double based system. Now, as you can see that we are changing from uh, integer to float, that means the whole protocol or the whole banking abstraction needs to change. No, the summation function, the percentage calculation, all those remain the same, just that the underlying data uh, storing or the data abstraction has changed. Okay, and basically that change is called what we call as data abstraction, or like you will later learn this in your like a bit later for Niket, when we shall be doing the object and classes, you will understand the data abstraction concepts, and for Dudika it will be next year for you. But basically what happens is you are hiding the inner working of your data variables. Okay, now in IPv4 addressing, the people who made it thought that, okay, for 4.9 billion, 4.8 billion जो भी है, like that's in billions. So who are the people, like how many people will be using internet? Only the universities will be using the internet. So we won't be running out of the representations for the internet, right? So they thought like this. But then what happened that closely and steadily people, the internet was spreading in the 1970s, 1980s, and it was like, okay, we need to do something. This whole system will no longer hold any water as the, because of the fast pace at which internet is now spreading. What to do then? The only solution was to increase the number of bits, which Niket has successfully pointed out, and that's what they did. That's why there's something called IPv6 exists, and there's a still about IPv5. We shall get into it later, but yeah. Now understand this 8-bit system representation in four segments. This had classes. Okay, IPv4 classes, and Niket, be very attentive here because a lot of MCQs will be coming from this particular segment. For Deepika, understand that next year you shall be having a lot of questions. Okay. Uh,
Okay.
so इतना तक तो clear है, right?
How's your
इतना तक
stream
है?
going? How's your stream going?
How's the stream going? Okay, that's a question that I don't expect. Yeah, the stream is going fine. Okay, no, you are not. Okay, let me see what's the error. Enough to. Oh no, it's fine. It's fine. It's higher than the recommend. So I'm sending it at a higher quality.
You are
Hopefully
very.
everything is fine.
You
Okay,
are.
let me
You are
let me
one
just.
giver.
Huh?
Have you earned something? Have you earned something?
No, currently not. Currently not. So um,
Oh, yeah.
this is the stream URL. This is the backup server URL. So I can just go on to this. Mm, I think I can just share this. Let me just ask my roommate there. Hey, Devanjan, can you check if my stream is going all right or not? What? I have lags. কথাগুলো কেটে যাচ্ছে? Hmm.
না না
Okay.
কথা ঠিক আছে
No, just give me a second. Let me just quickly. Mm, Internet is bad. Just hey Niket, just can you just give me 1 second? Let me check the stream real quick. It's fine. It's just a test stream.
ওকে
So anyway, I don't have any viewers who will be watching this. Just for
লল
yeah, it's true. Mm,
your YouTube channel is still not pointed, right?
no, it's not. Okay. Currently, no, there are no issues. There are no issues there. There are no issues. Why are you saying there are issues? Chilo. Okay, Devanjan is saying that there were issues. Hmm. I just pressed the button. Okay, let's continue. Okay, sorry for the brief digression. So, currently, do you guys have any questions about this IPv4
What
addressing
is
or
the meaning of our
formatting?
digression? Please explain.
Uh, basically means to like di- mm, digress means to uh, split your attention to another segment which is not relevant. Okay,
Okay.
so yeah. Okay, guys, I'm asking this question that do you have any like let's say lack of understanding in this IPv4 addressing or how the system is working? Can you understand the range? It
No,
is
no.
from zero
Very clear.
zero dot zero
Yeah,
dot
yeah.
zero dot
Easy,
zero.
easy.
Fine. Deepika, any issues? Do we have any issues here? Okay, these things silent. Are you there? Are you there? Yeah. Are you having any issues?
No.
No. Okay. Then we can continue. let's continue with the IPv4 addressing, and from here we shall be moving to the classes. Okay, let's see, do we have the notes for that? Yes. This will all be shared with you, so don't worry about it. Okay. Mm, what we have discussed,
through GitHub.
well, what do you think? What would be better for you? I shall be sending you both the GitHub as well as this notebook link. Okay, so you can access both of them. So
Okay, okay.
don't worry about it.
So
Okay.
can we make mind maps of our studies also?
Of
Like
course, use whatever you can.
I want to make a no, mind map of thermodynamics.
Okay, sure.
I
Do
am
it.
very obsessed with that thing.
Okay, you are making jokes, right? I know.
Yeah, yeah.
Okay, now next thing what we are going to do is the classes. Okay, these are the notes on the classes, and we better like let's just see pictures. Otherwise, कौन इतना जो है text अभी पढ़ेगा, ठीक है? Uh, this should have been a proper picture. Yeah. Mm, दिखाई दे रहा है?
Yes.
Okay. So there are different classes in your IPv4 addresses. Okay. What are those classes and what do we mean by classes? Understand that each and every, let's say, IPv4 address can be given to a particular specific domain of interest. Okay. And in that domain of
So what is the
interest,
domain of interest?
yeah, domain of interest means basically it can be government or maybe private companies or maybe reserved for uh, army or research purposes. Okay, and all this stuff. So
What
we
does
एक एक करके देखते हैं, एक एक करके देखते हैं, ठीक है? First understand कि 1.0.0.0 मतलब जो स्टार्टिंग है, ठीक है? मतलब एकदम स्टार्टिंग से लाइक आईपी एड्रेसेस उससे लेके 127.0.0.0 whatever be it. Okay, मतलब the first section for this first 8-bit section is moving from 1 2 3 4 5 6 7 8 1 करके 127 तक ये मूव कर रहा है, and of course with it can move all these other sections. Okay, move means change, मतलब 0 से लेके 255 तक कुछ भी चेंज होने दो, ठीक है? But the first section needs to is restricted from 1 to 127. Okay, that means this will have the number of hosts per network will be something like 16 million. Okay, just do the calculation how the 16. Okay, let me give you. Let me ask you, how is it coming to be this 16 million or something? Okay, I think it is 16 or 16. Um, yeah, it is 16 million.
1.6 million.
No, it is 16
No,
million.
1.6 million.
1.6. It's million, right?
1
Million
million
means
means 10 lakhs.
10
1 million means 10 lakhs.
lakhs, and this is
Uh,
what this is 160. No, if I remember, okay, I think I
oh,
forgot this
16 million.
million. It is 16 million, right?
Oh, this is a foreign. Yeah, it's 16 million.
Yeah,
Yes,
this
yes.
is million, so it is 1, 2, 3, 4, 5. Yeah, and that's 16 million.
Yes, 16 million.
To the
16
power
million.
6, to the power 6. Okay, fine. Now my question is how is this number coming? Okay, this is the question that I want you to answer right now on spot. Try calculating how is this coming.
PNC?
Of course, PNC is
PNC?
permanent communist. Of course. अरे आंसर दो कैसे आ रहा है? किसका मतलब कितना वैल्यू दूं पावर में ये बोलो.
16 মিলিয়ন মানে কত হবে? 2 টু দি পাওয়ার অনেকটাই তো বেশি। মানে তুমি কি
Yeah,
আনসার জানতে চাইছো?
I want you guys to give me the reason why is it coming to be 16 million, 16,777 जो भी है. ये क्यों आ रहा है ये बताओ.
পিএনসি ভুলে যাচ্ছি কেন? করতে হবে PNC
Yutika, can you compute it? Oh, have you done the permutation combination classes in your um,
না না
school
না না
and
স্যার পারমিশন কম্বিনেশন লাস্টে ফাইনালের পরে করায় ফাইনালে ওরকম মানে একদম হাফ ইয়ারলি আগের দিকে করায়
mm, mm.
বলছি আমি 60 মিলিয়ন কটা তিনটে এই টু টু এর এখন কত পাওয়ারে যে 60 মিলিয়ন হয় আমার সেটা মাথায় আসছে না আগে
No,
তো হয়ে যেত
you don't. अरे भाई कैलकुलेशन करो यार. ठीक है, I'm saying the answer. See, 1 से लेके 127 तक जा रहा है. उसके साथ साथ with that see that 0.0.0 जो है, this is what uh, this is changing or this is not changing.
changing the first section can be selected in 255 ways. Second can also be selected in 255 ways. Third section can also be selected in 255 ways. So 255 into 255 into 255, and the first section can be selected in only 126 ways. So 126 is that I am doing correct calculation.
हाँ करो करो, you are on the right path. चलो.
আরে এটা ক্যালকুলেট করে কত হবে ক্যালকুলেট করতে হবে দাঁড়াও ফার্স্ট জিরো দেখ আমি তো বলে দিচ্ছি প্রথম ওয়ানটা মানে প্রথম একদম যে ফার্স্ট এর পার্টটা ওটা 126 ইট ক্যান বি সিলেক্টেড ইন ওয়ান নাম্বার অফ ওয়েজ টু সিলেক্ট দ্যাট নাম্বার ইজ 126 ways. Second zero it can be selected in 255 ways. Third zero it can also be selected in 255 ways, and the last one it can also be selected into 255 ways. So only we have to do is we have to multiply this 255 into 255 to the power 3 into 126. I think
हाँ,
that will be the answer.
calculator, put it into the calculator. What's the answer that's coming?
Wait. Wait. Uh, wait. Sir,
Yeah,
you
I'm
are
waiting.
taking PNC classes.
It is
Oh no.
PNC.
আরে এটা তো কত আসছে এটা তো
Mhm.
90 is going over crores.
Uh, yes,
92 লাখ 8 কোটি তো মানে 10 কোটির উপরে বেশি গেছে
yes,
208
good.
কোটি 208 কোটি 92 লাখ 53
Yes,
হাজার 250
yes, good. So the answer will not match
না
this
না
60
না
million. Don't worry.
না
The
না
answer was
ম্যাচটা কেন না না তুমি আমাকে বলো না 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 1 মিনিট স্যার 1 মিনিট এখানে
because
সাবটাইটেল আমার কাছে ম্যাটার করে না তুমি আমাকে অঙ্কটা
because
বোঝাও
not
হ্যাঁ
অঙ্ক নয়, তুই যেটা করেছিস that's fine. Understand that what you did was correct. Because there is one more thing that we need to discuss here, which is look at it. It is called number of hosts per network. Okay. So how do we? There is a difference between host and client, and basically the number of networks and all this. Okay. So for that, we need to understand how this range is being like what do you call this? Determining defined. Okay. And what are the nodes which are actually accessible in a class A IP addresses. So with that, let's in number we will see. Okay. Give me a second.
তাহলে স্যার দেখো আমার আমি যেভাবে পিএনসি দেখলাম ঠিক পিএনসি করলাম তো
You did it correct. Okay. But the thing is
দেখো
that there
অঙ্কটা
is
তাহলে
one
ঠিক
more
আছে
point which no, there is one more point that we need to discuss to get to the 16 million. Okay. Class of a sorry.
কি হবে স্যার
Class
গুণ ভাগ বিয়োগ যোগ এছাড়া তো ম্যাথসে আর কোনো অপারেশনস হয় না
oh, bro, don't say that. Don't say that. Okay. So see. Yeah. This is what I want to discuss. Okay. Class A. There are the difference between network IDs and host IDs. Okay. Like here you can see that the class of IP address used to determine the bits used for network ID and host ID, and the number of total networks and the host possible in that particular class. Okay. So you will see that what happens that in a class A network, there are these 4 sections, right? And in these 4 sections, the first byte means the first 8 bits, okay, or the first section whatever, how I don't know how in more ways I can just target that first 192 वाला part. Basically वहाँ पे देखो उसको हम कहते हैं net ID, and all these other the sections are contributing to the host ID. Okay. Then class B in that way is the first two bytes, means the first 8 bits and the second 8 bits are dedicated to the network ID, and in the last two sections or the last 16 bits are dedicated to the host ID. Okay. In that
So
way, class
host
C
ID
is
is the
done.
ID which is, but the ID of mine,
The
the ID of
idea
the
of
user, the ID of the user that is using the network, right?
fine, kind of, it's fine. You can say it like that. So, mm, yeah, actually in
না না
class
তুমি বলো না আমি
11,
শুনি।
it's fine. Basically, understand in a network, everyone can either be a client or a server, or at most be this what you call routing stuff, repeater, and basically they're also nodes, kind of they're just forwarding network. So, mm, yeah, in that way we can say what you said is a kind of generalized way, and it's not inaccurate. I can't deny it. It's fine. So it's fine. So now let's go into understanding how this addressing is coming. Okay, and each and every section and all this stuff. So here is a class A. Okay, अब ये देख लो. The thing is that the higher order bit of the first octet. Okay, because okay, I should be opening that picture right now. This is called the first octet. This is the second octet, third octet, and fourth octet. If we missed it, the first section. Okay, the class A is always set to 0. Okay, it is the higher order bit बोला है. ठीक है, अब bit मतलब क्या? ये देखिए, ये तेरा 8 bits. ठीक है, यहाँ पे 8 bits में जो है वो always set to 0, and remaining 7 bits in the first octet are used to determine the network ID. Okay, so here the first bit has been set to 0, and the other bits are used as in the network ID. And the 24 bits of the host ID are used to determine the host is like basically it's segmenting out the what do you call this IP address, or the sections of the IP address before address. Okay, and that's why instead of like you are multiplying it, what you are doing, it should be something like 2 to the power 24, because
এটা আমি ঠিক করেছি। উফ।
oh, you did. You were saying 92 lakh or something, right?
হ্যাঁ মানে ওরকম মানে কত মানে 200 কোটি 208,92,53,250।
Hmm.
দেখো আরে ওই ক্যালকুলেশনটা তো তোমার এখানে দেখাচ্ছে, দেখো না ওই যে ওয়ানটা
Fine.
আমি তোমায় যেটা
Yeah,
বললাম, 127, ওই 127 আমি 126 করেছিলাম। ইস
you were saying something
বাবা।
92 lakhs or what?
না 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 92 ল্যাক্স না, আমি তো বললাম যে দুশো
Uh,
আট কোটি না
208.
92
Okay.
ল্যাক্স আমি বলি যে
Hmm.
আরে মেবি ওটা 208 কোটি হবে। হ্যাঁ 10 লাখের পর তো ওটা কোটিতে চলে যায় তাই তো নাকি?
Just say it in numbers.
হ্যাঁ মানে
It's fine.
আরে দেখো
Are you getting
টু
it?
জিরো এইট
Yeah.
নাইন
Hmm.
208,925,3,250, মানে বেসিক্যালি
Yeah.
আমি করেছি, আমি তোমায় বললাম তো 126 × 255 এর কিউব ব্যাস। এখানে এটা
Hmm.
127 করেছে ও।
Hmm.
একটা just ভুল হয়েছে।
Okay.
কিন্তু আমাকে একটা জিনিস বলো, এটা এখানে 2 to the power 24 - 2 কেন বললো?
Oh, the starting bit and the ending bit. Okay. Like two combinations are just manipulo. I've done that. Keep like gotcha whole problem. Like how if you have two poles, if you have three poles, how many gaps do you have it? Okay, it's something like that. So you have
হ্যাঁ
to
গ্যাপ প্রবলেম, গ্যাপ
minus,
প্রবলেম।
yeah, gap
ওই তো
gap problem.
ছেলে
So
মেয়েকে আহ, জানি জানি।
basically you're just
না না আমাকে
like
একটা জিনিস
subtracting
বলো,
the first and the last.
আমাকে একটা জিনিস বলো, ও 2 to the
Mhm.
power 24টা বার করলো কি করে?
Oh, that is because here let's go. This first one
দেখো দেখো এক মিনিট এক মিনিট এক মিনিট।
is called.
ফার্স্ট ওয়ান ক্যান বি সিলেক্টেড ইন 127 ways।
No, अरे वो नहीं
सेकंड
बोल रहा भाई, सुन. These are the host ID. This is the number of host ID. While discussing, we were saying ना, this is the number of hosts per network. कितने host तुम मतलब client है या के host है, ठीक है? तुम and we need to allocate some particular IDs to the network itself. That's why it is like ranges like when you change the first section, it can be 1 to 126. Okay, 1 to 126 are the number of networks that you can have. Okay, that is 126 number are the number of
আমি
networks. And if you just
তাহলে তুমি বলো
exclude
তাহলে
that,
আমি তাহলে কি
exclude, listen,
করছিলাম?
listen, if you just exclude that section, then the remaining are like 8 plus 8 plus 8. So 8 times 3 is 24. So you have 24 bits to represent the host network. Just like that, understand here in the class B, what happens is that you are using the first two sections or the first two octets, means it is 8 plus 8, 16 bits are already gone for your network, and then you have just 16 bits to represent the host ID. So it should be 2 to the power 16 minus 2, which is here. Okay, and the understand that here also. Okay, network ID
আচ্ছা
में
দেখো টু টু
to
দি পাওয়ার 16 তো
question
দেখো
करते हैं।
টু টু দি পাওয়ার 24 এর জিনিসটা যে হচ্ছে টু টু দি পাওয়ার 24 মানে আমার কাছে অনলি দুটো অপশন 0 আর 1, কিন্তু আমি তো আইপি অ্যাড্রেসে 1 টা 7 ও তো ইনপুট দিতেই পারি, আমার তো 7 তো আইপি অ্যাড্রেস থাকতেই পারে না?
I don't know. Oh, you are confusing it between that. Okay. See,
তুমি তো টু
this
টু দি
is
পাওয়ার 24 বলছো
see
মানে
see
আমার
see
কাছে অনলি
see
দুটো নাম্বার আছে 0 1।
see. This is the
হ্যাঁ
decimal
বলো।
representation. This is the decimal
হ্যাঁ
representation, and this is the binary representation. Okay. So in decimal, you can
হ্যাঁ
have any number from 0 to 255 because it is 2 to the
হ্যাঁ
power
হ্যাঁ এটাই
8.
নাম্বার।
Okay, but we are talking
হ্যাঁ
about the number of bits. Bits means you can have 8 bits and in each octet. Okay, so 8 bits in each octet means like भाई क्या बोल एक byte, one byte हर एक octet में है, और when we are saying the number of byte 2 to the power 24, we are adding this 8 bits here. 8 plus 8 plus 8, that's 2 to the power that's 24, and because each bit can represent two states, that is 2 to the power 24. माइनस करते हैं जब ये दोनों का मैक्सिमम और मिनिमम वैल्यू, दैट इज 000 and 255 255 255, those two IDs are subtracted. Okay, so that's why it is 2 to the power 24 minus the two specific IDs, and you have 16 million, that's 777, what will be the number. Okay, was that clear?
ঠিক আছে, ভাবতে হবে।
Okay.
না আমি
uh,
জায়গাটা বুঝতে পারছি। দেখো প্রথম সেকশনটাতে 127 টা নাম্বারের রেঞ্জ আছে। আমি তোমাকে বলো ফার্স্ট অক্টেটটা, ফার্স্ট
अरे
অক্টেটটা তো আমি
see, अरे इधर
ওয়াन
इधर पर, so listen, just read the first line.
the higher order bit of the first octet class is always set to 0. The remaining
हाँ
7 bits in the first octet are used to determine the network ID. The 24 bits of the
मतलब
host
stop
ID
stop stop stop,
are used to
यहाँ तक you read it till now understand here, this is what 192, right? This
decimal
192
system.
address, how is it coming? First of all, understand we are talking about the class A. This is a general address, this is not in class A. Okay, we are talking about classes. So in class A, at most it could be represented at 127, means यहाँ पे देखो इसका जो bit representation है या फिर binary representation है, the first bit here 1, this 1 should be 0. Okay, this 1 should be 0, and rest of the bits means 2 to the power 7. Okay,
7 to the power 7, okay.
okay, very good. 2 to the power 7 minus the first and the start bit, that is 128 minus
সবগুলো
2.
0 আর লাস্টে সবগুলো 1।
Yes, so and the first bit, this first bit is always 0. This first bit is
ফার্স্ট বিট
always 0 in the class A IPv4 address. Okay, please understand that how the questions will come. In your exam, it will be asked in a class A IPv4 address, the first bit of the network ID is set to option A 10, option B 1, option C 0, option D maybe what 1 1. Okay,
কিছুতে হবে, অল অফ দিস
Thi- yeah, these kind of questions will be there in your exam. Okay, now please do not ask me why is it like this, because it has been defined to be like that. Okay,
I have a question.
sure, go ahead.
Why is it 2 to the power 24 minus 2?
Oh, it is basically 24 माइनस, ओके। सो यहाँ तक तो इसको अभी क्लियर है। ये देखो, ये 0.0.0 हो सकता है, दैट इज all the bits here are 0, all the bits here are 0, all the bits here are 0, and or हो सकता है 1.1, sorry 1 क्यों बोला, sorry, very sorry, 255.255.255, which is all the bits here are 1, all the bits here are 1, all the bits here are 1. Okay, these two combinations are terminal combinations which are excluded. Now there are reasons why they are excluded, and currently I don't exactly know the proper reason, but what I think is basically the terminal cases are used to determine the edges of the class, like distinction between one class to another, but that could be done anyway. Probably this is because of the parity reduction, or like it happens that sometimes you want to send to one address and all the bits are one. There is a higher chance that one bit might flip or something like that. But I don't exactly know the reason. I'm very sorry for that. But I can, yeah. Give me one thing. Let me just even search it. Why the terminal
এখান থেকে পেন্সিল প্রশ্ন আসবে নাকি?
addresses in class A IPv4 are not counted? All the zeros are not counted as usable. The all zero, yeah, जो बोल रहा था all zero. The network addresses itself and all one's address is used for, okay, reserved for special purpose and not assigned to, okay. Yeah, I did not know exactly the reason. Now I know. Sorry. Uh, I don't know everything, but even while teaching, I try to understand that what is happening. Okay, let me see. Okay, there are articles for this. So what is it saying? It is saying that the all zeros and all ones, मतलब जो अभी बोल रहे थे ना कि यहाँ पे जीरो, यहाँ पे जीरो, यहाँ पे जीरो, यहाँ पे वन, यहाँ पे जो है मतलब वन, मतलब 255.255.255 means all are one here, all are one here, all are one here. That kind of address are not counted as usable host addresses. The all zero address represents the network itself, means it is a self-referential addressing. Okay, and all the ones address that is like here 255.255, so 255, that is used for broadcast communication on that network. Okay, what is a broadcast communication? Broadcasting means when you are sending information to all the other clients or nodes in the network. Okay, that is called broadcasting. Okay, or it can be done to specific host and network, network configuration, but that's a different matter. These addresses are reserved for special purposes and are not assigned to individual hosts. So yeah, was that like clear enough answer for you? Or we can dig deeper into why it's like referencing to itself. But for now, let's not do that. We can do that later. Is that fine?
Yeah.
Okay. Niket, fine? चलेगा?
হুম।
Now let's continue our hunt for like different classes. So class A was what? Here the first bit was 0. Understand here. Here the first bit was 0 and all the other bits could take whatever combination that they want except the terminal wala. Hmm. कहाँ गया? Where is the article? Yeah. So now in the class B, here the highest order bits, the first octet, are always set to 1 0. Okay, and okay, Nikhil, I can say this kind of in a more assertive manner that in your MCQ questions, you will probably have the question from class B, not from class C. Okay, like
ওকে।
इतना मैं गारंटी दे सकता हूँ कि अब तक जितना पेपर देखा है उसमें दिस क्वेश्चन इज वन ऑफ द मोस्ट कॉमन क्वेश्चंस दैट
ক্লাস জিরো।
highest class B, and here the first two bits are set to 1 0. Okay,
দিস ইজ ফিক্স, মানে ওগুলোকে তো চেঞ্জ করা যায় না, সো ওগুলোকে পারমিশন কম্বিনেশন লাগানো যাবে।
yeah. So if that is clear, then basically we can do the calculation again. वो कैसे करते हैं देख लो. Yeah. So here the first two sections or the first two octets are now totally unusable. Okay. If I remember correctly, it was here. Where is it? Where is it? So as you can see, this first two are totally unusable, and after that, only the other two are usable. Usable, not unusable. क्या बोलूं? Network ID के लिए. And the last two are for your host ID. Okay. And usable means like in your network, some like as we are the host most of the time in our networks, until we are like senders and receivers and servers and all this. So um, and in those cases we only have these two last bits. Okay, so last two sections means this one byte 3 and byte 4, this third byte third section, fourth section. If we just combine it, we have 8 plus 8, that is 16, and minus the terminal cases, that is 2 to the power 16 minus 2, which is 65,534. Both addresses we can have. And of course, the first one will be 2 to the power 14, which is this thing, like 16,384 network addresses. These are unique addresses that we can have. Okay. Now, I want to say a very important point here, which is look at this. This is a different classification of the simple class A and class B and class C. You will see that this is the public domain and this is the private domain. Okay. Fine. So, what do you mean by public and private? Like, what have you seen? तो तुम्हारे आइडिया से क्या लगता है पब्लिक और प्राइवेट क्या होगा, नेटवर्किंग में क्या होगा? हेलो हेलो.
No idea, sir. I only
No
know
idea.
functions domain.
Functions domain. Okay, okay, fine. Dudika, what about you? Any idea? कुछ idea दो. कुछ तो मतलब.
Private, does it mean private users like us, we are private users. Public means public. What do I say? Public means the school using that network, something like that.
Mm, not really. Okay, okay. Let's understand this.
Or maybe I am wrong.
Okay, okay. No issues. I can't show you my IP address on the while streaming, but what happens is that suppose you
How can we
have,
see our IP address?
how can I see my IP address? Use command like ifconfig or ipaddr.
No, no, no.
Okay,
In my phone. My phone. I'm using my phone right now.
you can use any online IP addressing tool. Okay, okay. I shall
So
show
we
it.
can use so we can use the IP address to hack, like if we get the
Yes,
access of IP address, can we
yes, yes,
hack
yes,
something?
yes, yes, yes.
So sir,
And
আমাকে
mm,
দেখাতেই পারো, আমি হ্যাক করতে পারি না।
okay, bro. Remember that this is streaming. Okay. Okay. So,
Yeah, yeah.
what I was going to say? Yeah, private and public network. So currently, suppose I'm here in ISER. Okay, you will if you are in IITs or ISERs or like whichever college you will go, maybe whenever you are going to work in that company, a company will have its own private network. Okay, and that private network will be running its own domains. Okay, means it is their own domain private communication like addresses that will be given to your
So what do you mean the domain of
nodes.
the private network?
Spread कितने सारे like उस जगह पे कितने लोग हैं, कितने nodes हैं, that's what I'm saying. Okay, and in that spread we are saying that from 10.0.0 to 10.255 255 yeah, you can have these many devices uh, in a private uh, in the private domain of class A IP addressing. Okay, fine.
Yes, yes, fine.
And this is just a segmentation that is done. then what do you like private means you set up, suppose you set up your own network. You have a router in your home, right?
So what is the
So
uh,
so if you set up your own network, then and currently home routers are like what? They have maybe at most 5 devices or 15 devices, maybe 30 devices. Okay. 30 devices means like it's probably an office network, but so, come to any university and they will have a private network which will be spread out, and it will have something like what, hundreds of devices. Okay, like 1,000 devices. If you just consider ISEC, okay, our college. So there are about 3,000 students. Okay, like total. So if you have 3,000 students and everyone has, let's say, 3 devices minimum. Okay, that is what, 6,000, and you have 255 times 255 times 255. That many addresses, unique addresses that you can give to that private domain. Okay, but that is under class A. You can also come under class B. Okay, and these are generally used where governments have large number of hosts.
so which type of class we will use? Who will determine that thing?
Okay, that's a good question. It is generally determined by what devices do you have, what's the network that you are connecting to, or you can actually, you know what, you can actually create your own private network. मतलब खुद का domain, खुद का network बना दो, खुद का address बनाओ. Okay, you can literally create your own IP, मतलब V4 protocol using like um, okay, I was going to say C because basically a lot of these things are done in C. Okay, and yeah, a huge chunk of the internet that you see today is written in C. Like the whole networking, as you can, like this web sockets and all this. We shall understand web sockets as well if we have time in this class. And probably we are already too much into it. Okay, see, let's see how much we can cover. And then like that we have class C and class D and also class E. Do we need to go into much details because it is kind of the same thing, but what happens, the number of devices are now reducing. Okay, but a special thing happens here. This class D and E are now being reserved for, like, answer D is reserved for multicasting and E is reserved for experimental. Okay, and these special devices are there. Okay, these special IP addresses are there. These are called loop back testing. Okay, what are loop back devices? वो भी दिखाऊंगा. Don't worry. Okay, loop back basically means mm, you will see that is sometimes okay. I don't know how much you have done terminal stuff, but there are these devices called WLO, LO. Have you seen this? Have you seen these keywords? LO, WLO,
No,
WLAN.
no, no, no.
Okay, fine, fine. We will understand this, but थोड़ा थोड़ा करके भाई. अभी तक इतना तक क्लियर है तो कि क्लास ABCD क्या हो रहा है? Any question?
Uh-huh. No
Networking is
questions.
networking is a bit difficult. Suppose here I am leaving a few parts which I am going to say that I will explain later because you need understanding of other parts to understand this. Okay, so it's a bit difficult in that way.
Okay.
Please, if you are feeling uncomfortable in understanding anything, let me know. Now, we have done the
Sure.
networking fundamentals. We have done IP
So
addressing.
my question,
Next,
another question is, which
hmm,
type of IP address we use? So who will decide that thing? Whether we will use IPv4, whether we will use IPv6, who will decide that thing? Like,
like it's a very good question that who decides. It's a combination of what you are using. Okay, suppose your ISP. So ISP is your what?
what is
Internet service provider.
ISP?
Yeah,
Oh,
ISP
acha.
means your internet service provider. So who is your internet service provider? Do you have that information? Like, what is it?
Alliance most probably.
Hmm?
Alliance.
Alliance. Okay, very good. That means you know that the company that is giving you the internet. Or Dudka TXC is
Yeah.
using a mobile network, right?
না স্যার আমার তো জিও 1 GB পাতে if I use mobile network কিছু বলার নেই
Okay. So yeah, whatever be it. So in your you will see that is this ISPs, they have something is called the dynamic host configuration protocol. Okay, and this dynamic host configuration protocol is not only there in your क्या बोलते हैं इसको ISP. Uh, this I think is also used in your mm, nodes. Let me just search it up. Like, who is mm, this is a question that is a good one. Hmm. Okay. Okay. Too much stuff. I just read it like how it happens. Okay. So how do ISPs do the dynamic host um, assigning that? Because this assigning this is a communication protocol. Okay. Configuration protocol. Okay. So uh, like suppose
Who
if you have a
decides that?
hmm, so
So
this is
does the ISP decide the type of IP I'm getting? My type of IP address I'm assigned to.
no, it kind of depends on like these host of things. Okay. And these things are pretty complex. Like even I don't know that much details into like how these things are actually working. Okay. So I just probably
Okay.
know a few things like uh, peer-to-peer, LCP and all this. No, this is not peer-to-peer, this is PPP. PPP, LCP, handshakes. Okay. So these are handshakes means these are basically one uh, peer to not peer, one network to another peer that actually communicating that okay, this is me and this is you. We know each other or we are configured by the network to know each other. Okay. And if I just go and search it here, oh no,
Theta
what
আবার
it
কি
is.
singer?
I have no idea what V. I just wanted to copy
Oh,
this.
you are a Korean fan.
I am not a Korean
You are
fan.
team আরে স্যার সব মেয়েরাই কোরিয়ান ফ্যান হয়। ও না সরি
Okay.
বলছি।
So it is a crucial part of establishing a point-to-point, yeah, point-to-point peer-to-peer protocol. Okay, connection. Mm, currently, I have not that much idea on this internal working. Let me just read it up. I shall try to clarify your question later. Okay, this is a very good question.
আচ্ছা
Give me a second. No, no, give me a second. Let me just write it down. Uh,
স্যার স্যার টু বি অনেস্ট দেখো তুমি জানো না মানে তাহলে আমার আমার আর এর বাইরে
oh, let me just make a NKDIR networking. CV networking. So let's make a Vim questions. Like last time I just did it, it's generally done by ISPs and is
So
dynamic
why do
hosting.
you always make .md file not .txt files?
Oh, it just gives me a like nice preview. That's it. So currently your question is how our devices are getting their IPs. Okay. So
Which type of I always.
yeah, I'm just writing it in a general way. I shall read up on it. I shall answer it next class. Okay. Thanks for the question. Thanks. Okay. Sadly, I
Yes,
can't
sir.
answer it now, but let's continue. The subnet mask. Okay. So, so as you can see, this whole diagram, here not only we have all this thing, there is something called default subnet mask. Okay. And basically, what the heck this subnet mask is? Okay. Um, Let me just think. How many of you have heard the phrase that I was crying under the mask or something like that. Like that anime moment where you are just crying, you don't want to show your emotions. हाँ अरे कुछ तो बोलो मूवी में तो कभी तो देखा होगा लाइक आई वांट टू हाइड माय टीयर्स अंडर द रेन ऐसा कुछ तो कोट कभी तो एक कोट या फिर
ইয়া ইয়া
लाइक
এটা তো তোমার চার্লি চ্যাপলিনের কোট যে আই
yeah
অলওয়েজ ওয়াক ইন রেন সো নোবডি ক্যান সি মাই টিয়ার্স ওটা এরকম সামথিং লাইক দ্যাট ছিল
yes
একটা
yes
কিছু
so basically means what we don't want to show our unique IDs, right? We don't want someone to understand
এটা
our
হচ্ছে ইট ইজ আ ভেরি কি বলে মানে বয়েজ ইমোশন স্টাইল মানে দে
as a
ডোন্ট লাইক টু
boys.
শো অফ দেয়ার ইমোশনস
Yeah, so
ডু ইউ এগ্রি উইথ
that's true,
দ্যাট
that's
থিং
true.
প্লিজ
I do,
এগ্রি
I agree, I agree. But see, that's not something that we should be discussing now. Basically, I was just giving that story just to understand that
ওকে
this masks, what do they do? Now, suppose I wear a mask, okay, and I hide my emotions. Say I wear a mask of Power Ranger, some let's say Power Ranger Mystic Force. You wear a mask of something like say I take the uh, Green Ranger mask or Yellow Ranger mask. You take the Red Ranger mask. Let's say another person takes the blue. The Deepika takes the Blue Ranger or the Pink Ranger mask. Okay, or maybe the Yellow Ranger mask, whatever. So everyone can have our different mask and we can like our own उसके अंदर हम रोए हंसे जो करना है करें ठीक है that's just a joke but basically now someone else comes okay someone else means like some new person comes and he sees the mask so they can distinguish between one and other person through the help of that mask okay we are not talking about the उसके अंदर तुम क्या कर रहे हो whatever so basically in networking what happens we have this kind of mask just to uh, like differentiate between the network portion and the host portion okay like basically I was saying that उस मास्क के अंदर हम रोए हंसे क्या करें अब ये समझ लो कि उस मास्क के अंदर तुम नेटवर्क वाले हिस्से में हो या फिर तुम क्या बोलते हैं उसको होस्ट वाले हिस्से में हो उसको हम डिफरेंशिएट करना चाहते हैं ठीक है तो उसको कैसे करें उसको उसको करने के लिए ये वाला जो है सबनेट मास्क हम यूज करते हैं ओके is that fine let's read up on it a little bit here you will see that let's go to class A and there has to be this line about subnet mask if it's not there then probably not a good like article to read Mm, yeah it is there see this the default subnet mask for class A is C 255 is constant here and x dot x dot x okay this is the subnet mask and then if you just move on to class B then this is 255 उसके बाद जो 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 मतलब जिस मास्क के अंदर तुम देख रहे हो ठीक है क्लास सी के देखना 255 तीन बार आएगा ये तो तीन बार आ गया क्लास डी में देख लो ये कहाँ गया इसका सामने कहाँ गया ओ क्लास डी की बात कर रहे हैं ना इसका तो नहीं है सॉरी मैं तो भूल गया इसके बाद तो नहीं होगा क्योंकि तीन बार आने के बाद is basically used for multicasting and what you mean by multicasting and broadcasting means you are becoming the server and you are giving outputs to the other nodes okay so it's a different thing थोड़ी देर बाद जब थोड़ा क्लाइंट प्रोटोकॉल पीयर टू पीयर प्रोटोकॉल सर्वर क्लाइंट प्रोटोकॉल करेंगे उसके बाद इसमें फिर से आएंगे ठीक है we shall come back to this class D again but subnet mask is basically something that differences between the network part and the host part इतना तक तो क्लियर है ना कोई प्रॉब्लम तो नहीं है
না না নো নো
okay now next what to do let's oh yeah we actually kind of skipped the IPv6 in a way let's go to IPv6 okay don't worry not much questions will be there we will just see the representation and that's it okay let me just get a good picture IPv6 probably this whole class we were just discussing IP addresses right um, like just discussing the IP addresses has taken up around what 1 hour or something like that
Sir, I have to mug up this thing, whole things.
why were you not understanding anything
আন্ডারস্ট্যান্ডিং দেখো একটা ক্লাস এ তে মানে একটা সার্টেন ডেফিনেশন, প্রথমটা জিরো, ক্লাস বি তে ওয়ান জিরো, এগুলো তো ভুলে যেতেই পারবে না।
Um, I don't know. It sounds very trivial. It's very simple. Like you just need to understand. Okay, there are just four sections. First section में बस पहला वाला बिट जीरो है, दूसरे में जो है वन जीरो कर दो, इसमें जो है ऐसे करके चलेगा मतलब. I don't know. It's kind
স্যার
of
এই সেম
simple.
কথাটা স্যার এই সেম কথাটা ফিজিক্স, কেমিস্ট্রি, ম্যাথস টিচাররাও বলেন যে জাস্ট আন্ডারস্ট্যান্ড ইট, বাট দেয়ার আর এন নাম্বার অফ ফর্মুলাস।
Okay. One day you will see that okay, this is very simple. Fine, fine. No issues.
আরে স্যার তুমি জানো না, আমি লিটারালি ক্লাস ইলেভেনে উঠে মানে কোঅর্ডিনেট জিওমেট্রি যখন চালু করেছিলাম, আমি লিটারালি ভাবছিলাম যে আমি হিস্ট্রি পড়ছি না ম্যাথস পড়ছি, মানে এত ফর্মুলাস।
Fine.
আর
See,
ইন্টিগ্রেশন তো ছেড়েই দাও।
mm, I'm not going to say anything there because even in class, yeah, when I was there, I also had to remember a lot of formulas just to get through the course and get through the
ইয়া ইয়া
JEE advances, whatever. Let's go. IPv6 addressing. So instead of having those, let's say, four sections, we now have how many sections? 8 sections. Okay. We now have double the number of sections, and each section is consisting of 16 bits. Okay. Instead of 8 bits, it is 16 bits. And now you will see that okay, there are 16 bits. How do we represent 16 bits? 16 bits, मतलब ये देख लो, right? Don't confuse the bit configuration. Oh भाई उसका picture कहाँ रख दिया अभी? Uh, just so that we clear. See, instead of like there are 8 bits, okay. Now you have like और एक जो है 8 bit का जो है block है, ठीक है? Total 16 bit. समझ में आया? There are 16 bits here. So 16 bit को represent करने के लिए अभी कितना decimal होगा? Do you know how many like what
15
what decimal
15
number? Huh? No, no,
কত
not
15 হবে না?
15, not 15. See, there are 16 bits. Okay, 16 bits means
আচ্ছা
there
16
are
বিটস।
16 to the power 0, 16 to the power 1, 16, sorry, 16 क्यों बोल रहा हूँ, sorry, 2 to the power 0, 2 to the power 1, 2
আচ্ছা
to the
তাই
power
নাকি?
2, 2 to the
ইভেন
power
2 টু দি পাওয়ার
3,
16, 2 টু দি
2,
পাওয়ার
2,
15, 15 স্যার।
2 to the power 15. And what is the value to the power, like what's the value for 2 to the power 15?
হ্যাঁ, জানি না।
2 to the power 10
2
is
টু দি পাওয়ার 10
1024,
অব্দি
right?
জানি।
1024,
হ্যাঁ 2 টু দি পাওয়ার 10, হ্যাঁ 1024।
just do it. 2 to the
তাহলে
power 10,
8
listen now,
4
listen,
ওই
listen, listen, listen.
2048 হচ্ছে। আচ্ছা 10 10
Listen, listen. 2 to the power 10 is 1024, then হচ্ছে 2048, then it is 4096, then 4096 into 2. into 2 नहीं, into क्या करना होगा उसको जो है 4 करना पड़ेगा, तो क्या आ जाएगा? तो 4 नहीं, सॉरी, होगा 8, 8 होगा, 1 2 3 3, because that is 2 to the power 12, yeah. So that will be something like 32,000 something. Okay, that will be the value. So there, so to represent a 16-bit number in decimal, I have to write 5 digits. Okay, 5 digits in decimal, right? So what they chose to
So
use.
how do you determine the 5 digits?
Huh?
How did you determine that 5 digits are only required to represent 16 bits?
So if you want to represent 16 bits in decimal, it will be what? 2 to the power 15, which is around 32,000 something. Okay. So you can write something like 1, then followed by 4 zeros or something like that. But what they chose to do a more compact form. They chose 60 hexadecimal numbers. Okay. So they chose hexadecimal numbers to represent each block or each section or each. This is called what was this? Mm,
Why is it 2 to
what?
the power 15 and not 2 to the power 16?
Oh, 2 to the power 15 or 16. See, uh, here, if I show you this one, just understand here, it is what? 2 to the power 0, right? This is 1 times 2 to the, like 2 to the power 0. This is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power. Okay, so yeah. Now if you go back here, mm, So we are using hexadecimal numbers. So it will be like from 0 to F. Okay, F means 15, 1 5. So instead of using decimals representation, we use a hexadecimal representation to represent each and every section of it. Okay, and that's it. Now the total number of bits. This is a question that sometimes come in your exam. That how many total bits are there in an IPv6 addressing or address? Okay, the answer is 128 bits, and if it asks for each section of that address, then it is 16 bits. Okay. At this point, you just remember till this part, and if you want to know about the classes of it, you can. But if you have it, this unicast casting we will do after protocols. Okay, that's the issue. If I start from something, I also have to pause it, do another thing, then again come back because networking is a bit complex. Even I don't know a lot of things in networking. I probably know nothing in networking. Okay, I am just a total beginner in it. So yeah. mm, if I have, yeah, gig for gigs. Oh, just one more thing. If I go here, yeah, I was looking for this one. You currently don't have it in your syllabus. Okay. And what do we mean by unicast and multicast? We shall do after we do a little bit of the network protocols. Okay. After that, we will go back to casting and everything. And these are the amount of addresses that are currently used. This is the fraction of address spaces. Like IPv6 addresses, just count the total number of devices that can be connected in a network given the IPv6 addressing. Total number of devices in IPv6, and it is 2 to the power 128, which is this huge of a number that probably humanity will never exhaust. Okay, hopefully we are now thinking this will be
Hopefully,
enough.
no. It
Huh?
will cross. It will
It will
cross.
cross.
India will cross it first.
See, um, yeah,
আমি
so we
আর
are
কিছু
done.
বললাম না তুমি লাইভ স্ট্রিম করছো বলে নাহলে আরো কিছু
Hmm.
বলতে পারতাম যাই হোক
Okay. Next, let's do subnet mask. Subnet में वो हो गया 32-bit subnet, and okay, just understand that the subnet mask in this IPv4 is 32-bit, and then this is 128-bit for your IPv6. The questions will be like, what is the size of the subnet mask in bits for IPv4 or IPv6? It's 32-bit and 128-bit respectively. ठीक है? चलेगा?
হ্যাঁ হ্যাঁ
Okay,
ডান
let's go.
ডান
Done. Next, binary one corresponding subnetting. We will do that a little bit later. Next, we can go into the networking models, that is OSI model, TCP model, and a comparison. Okay, so let's do we have time? What's the time right now? Okay, we can cover up the OSI model. We can probably introduce the OSI model right now, and later we will get into the uh, nitty-gritty of each and every layer of the OSI model. Okay, and
oh,
understand that you.
query did you write what query did you write to this notepad what is this AI name of the AI
Array, notebook LLM. At the beginning of the
but
class, I told.
what
Na?
query did you yes
Hmm.
what query did you write to notebook 11 that it has made so nice representation that I am asking
Oh, this is a deep research on networking. I used like Google
no no
Gemini's
like what
deep.
type of how did you write the query
Oh, you just say that give me do a deep research on this concept. Okay, include this part that I just say, that include OSI model, include subnetting, include this, and also other similar topics, and you just with a whole research exported it into a. Give me a second. Let me show you. So
you can use also GitHub Copilot also it can do the same work
no, there is a limit. Okay, there is a limit in those. understand Gemini has a 1 million.
Copilot also has a limit.
Yes, yes. So this is it's about loading. Yeah, it is loading right now. So this is the deep research that we did. Okay. And this was later exported to a document, and that document was given to this Gemini for making this kind of beautiful diagrams. Okay. Acha. All
Okay.
these will be shared. Do not worry. Okay, everything will be shared, so you will have access to everything. Now, understand
Through
what is
GitHub
an
only, right?
OS? Yeah, of course, GitHub. So, what is an OSI model? OSI basically means your open system intercommunication. No, because communication on the term. Oh, man, I literally forgot the full form. Okay, let me just click on it. I forgot the full form. Will it actually give me the full form? Let's see. Open system
Interconnection.
interconnection, not communication. Sorry. Uh, yeah, but मैं sorry बोल रहा हूँ. मेरा एग्जाम नहीं आएगा, तुम्हारा आएगा, ठीक है? So please remember the full form. Okay. Don't be like me who
Yes,
forgets the full form.
yes.
Okay. Then understand that it is basically a not a protocol. Basically, it's a model that every device, every networking device has to follow to be able to access or send requests. Okay. मतलब ऐसा है कि suppose तुम अपने बारे में सोचो, like think about yourself. You are following a model, right? The Indian education model. You are following through classes from class LKG or KG, or class 1 to class 10, then you're doing high school. Okay. Finally, then you do maybe engineering, technical degree, science degree, whatever. And then you get into the workforce. And to get into the workforce, you have to follow all this through. Okay, this model. And because you follow this model, you now are able to communicate with the society, with the work culture. Okay. And think of OSI model as something that is given that has to be followed by each and every node in the device, in a node in the network. And if they follow this architecture, if they follow this model, then only they will be able to communicate with the network or internet. Okay. And this OSI model is basically a conceptual framework. Okay. This is just for understanding how network devices are actually working. And there are 7 layers. And these 7 layers, okay, remember, very, very important thing that I'm going to say this, which you might not like at all. Okay. So very sorry for that. You have to remember the model layers in order. Means you can't say
কোনো মানে আছে?
the network layer as the first layer, then you say the data link layer. You can't do that. It has to be in a particular network, either ascending or descending. So the reason I'm giving, just give me a second. But first, थोड़ा mnemonic दे देते हैं, ठीक है? Mnemonic देना पड़ेगा, right? So Niket, please write the mnemonic somewhere. I'm not writing it here. Okay. Uh, it is what the physical layer.
দাঁড়াও।
Then yeah, just write the mnemonic. Deepika, you can also write it because uh, you both will be giving daily in 1 year or 2 year time. So understand that in your day you have used a lot of mnemonics to remember formulas. So please इसके लिए भी वही same कर लो, ठीक है?
না না স্যার,
इसका
এটা
is
একটু সত্যিকার কথাই বলছি। তারপর লেয়ার মুখস্থ করছি, নিউমোনিক্স মুখস্থ করছি, মানে একটা জিনিসই তো মনে রাখা দরকার নাকি?
yeah, of course. तुम अपने क्लास में तो ऐसा नहीं लिखोगे कि वो हीलियन आर्गन नियॉन क्रिप्टन हीना ने हीना क्या है हीना
না না
ना
স্যার,
हीरा
সত্যিকার বলছি আমি
कुछ
কিন্তু,
ऐसा था.
না
हाँ.
আমি কিন্তু স্যার কি বলে, আমি কিন্তু আজ অব্দি কোনো কি বলে ইনঅর্গানিক কেমিস্ট্রিতে কিছুই নিউমোনিক ইউজ করিনি।
Okay, that's great. But अभी अभी मैं देख रहा हूँ. If you want to use it. If you don't, but just give. Okay. I
আচ্ছা দাও।
used in my whole days to remember this OSI model.
The
Okay.
only mnemonic I used in chemistry was your periodic table song. That's all.
Hmm. Hydrogen, helium, lithium, beryllium,
Oh
boron,
yeah,
carbon,
that
everywhere.
it, it was a
Yeah.
damn good song.
Okay, good. So see, the mnemonic is please do not throw sauce pizza away. Okay. फिर से बोल देता हूँ.
দাঁড়াও
Please
এক মিনিট।
do not throw sauce pizza away. Okay.
আচ্ছা এটা কিসের নিউমোনিক বলো তো, নিউমোনিক্স বলো তো এটা কিসের?
For remembering the different layers in OSI model. Okay.
ওএসআই তো?
obviously. And now you can remember it by layer as well. If you remember it by layer, that इसके बाद ये आता है. Now understand how the questions will come. What is the layer just above the network model? What is the layer just below the transport layer or session layer? ऐसा टाइप का क्वेश्चन आ सकता है, ठीक है? Or it can be a little bit tricky as well. Like, what is the layer that comes just below the layer which is responsible for end-to-end communication devices, services for application? मतलब it gives the
That means we have to also remember the definition too.
no that function. You need to understand their function. That's
Function.
okay. Do you understand the nature of questions that generally comes in your exams? From your exam point of view, I'm saying.
Yeah, probably.
Probably. Okay. Do you have issues with it?
No.
Okay. Like you are quite quiet. So be like what do you call this? Be more brave and speak up.
So বলছি মোস্ট প্রবাবলি এরকম টাইপের
Hmm.
কোয়েশ্চেন
If you are done, we
বিএসসিতে
can continue.
এমসিকিউ এমসিকিউতে মানে কেস স্টাডি বেসডে আসে নাকি?
Case study based money. What are you asking for?
কেস স্টাডি মানে কেস স্টাডি বেস তোমায় বোঝাই কি করে? আচ্ছা, কেস স্টাডি মানে তুমি কি বলো, মানে তোমাকে একটা গল্প দিয়ে দেবে, ওখান থেকে তোমার প্রশ্ন, মানে কম্পিটিশন পেপার ওরকম জিনিস আছে কি না?
No, no, no. It's direct question. Direct question. Don't worry.
না, আমাদের যেমনি ক্লাস 11-এ কেস স্টাডি দিত, ফর এক্সাম্পল এই সাইবার সাইবার সিকিউরিটি চ্যাপ্টার থেকে দিয়েছিল একটা গল্প দিয়ে দিয়েছিল, যে একটা বেসিক্যালি একটা তোমার একটা মেয়ের নাম দিয়ে দিয়েছিল, ওকে সব সাইবার
Oh,
হ্যারাসমেন্ট দিয়ে
listen,
বলছিল
listen.
ডিটারমাইন দা।
Listen. That is for class 11. Those questions are not set by your board. Okay. This is class
ওকে,
12. So board
সো
exam
নো
paper.
নো কেস স্টাডি
Board.
টাইপ কোশ্চেন্স রাইট?
Those are not exactly case study. They give you a scenario where something is happening. You need to identify the type of,
ইয়া ইয়া,
let's say,
হ্যাঁ
breach,
হ্যাঁ,
let's say
গট
privacy breaching or bullying, cyberbullying, or whatever it was.
ওই 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 হলো,
Mm,
হ্যাঁ হ্যাঁ,
mm. So
মানে এরম
that's
দেবে না
also
বলছো?
no. That is the way. Otherwise, how can you give a question on cyberbullying other than just asking the definition or what is cyberbullying? Okay, there are not
না না, সেটা
many other
বলছি না, আমি বলছি তাহলে
ways
টুয়েলভ,
of asking.
ক্লাস 12-এ এরকম কিছু দেবে না বলছো?
No, no, it won't be. It will mostly be direct questions, so don't worry. Okay,
ওকে,
so let's go from layer to layer. So what is the first layer? First layer is the physical layer. Okay, and this basically deals with the physical like devices. Means let's say your hard disk, your hard disk, to RAM, the chip inside, the Wi-Fi card. Okay, it is connected deep within the hardware architecture of your device. Next comes the data link. Okay, this is the data link layer, which basically focuses on the reliable data transfer between two nodes on a like physical link. I at this point I feel like I'm
আচ্ছা
reading
এখানে
it,
তোমার কাছে জিনিস,
which is
হোয়াট
not a
ইউ
good
ডিফাইন
way.
বাই নোটস? নোটস মানে কি ওয়েভস এর নোটস এর কথা বলছো?
No, not those nodes. I'm talking about the nodes or the what do you call this, clients or hosts or let's say anyone who is connected to a network is a node. Okay, it can be a printer, it can be a smartphone, it can be your computer, it can be your mm, monitor, it can be anything which is connected to a network is a what do you call this? Is a
আচ্ছা
node.
আমি তোমায়
Okay.
একটা, ওকে গট ইট। আচ্ছা আমি তোমায় একটা পাতি ভাষায় তোমাকে যদি কেউ একটা লেম্যান জিজ্ঞেস করে, জাস্ট পাতি
Mm-hmm.
ভাষায় তোমাকে বলো একটা তুমি মানুষকে কি করে বোঝাবে, পিওর
Mm-hmm.
বাংলাতে বলছে, একটা পাতি মানুষকে তুমি কিভাবে বোঝাবে একটা ডেটা আমার ফোন থেকে তোমার ফোনে যাচ্ছে কি করে
Mm-hmm.
উইদাউট এনি ফিজিক্যাল লিঙ্কিং বিটুইন ইয়োর টু ডিভাইসেস? কি করে যাচ্ছে দুটো, একটা ডেটা থেকে আরেকটা ডেটাতে?
Layman means suppose someone has no information about what networking is or anything, right?
না মানে ধরো, হ্যাঁ তাকেই তুমি যদি ধরো বলে দাও তুমি কি বলতে, এই যে ডেটা ট্রান্সফার হয় প্যাকেজ টু প্যাকেজ, তুমি যেগুলো প্রথম থেকে বলছিলে রিডাইরেক্ট করে যায়, অল ওকে, তো মানে আমি ধরো যে একটা কোয়েরি পাঠাচ্ছি যে আমার এই সার্ভারটা খোলা দরকার, এটা মানে হাউ ইজ ইট গোয়িং টু দ্যাট
The best way to say it is,
মেন সার্ভার?
uh, I get it, but it's very difficult to say it. Let's say, who am I? It would be a very test of like teaching capabilities for me. Okay, let's see. Suppose I'm explaining it to someone like my mother or someone like my grandfather or some uncle on the road. Okay, who knows nothing, who just uses his smartphone and sends WhatsApp messages. Okay,
Yeah,
he or
yeah,
she wants to understand, let's say, when he's sending a picture to his son, okay, or to her son, how the picture is like being received or okay,
yeah,
getting to one person another. So that would be something like you are sending information, right? So I have to explain that, say, it's like you have a paper. Okay, the paper or say the envelope will take a picture, a video, or whatever information that you are sending. Okay, it will take a picture. Then what it will do, it will, okay, let me make it a bit more interesting. Trying to make you also understand the concept of encryption. It will take the picture. Okay, then it will cut it. It will cut the picture into tiny, tiny pieces. Okay, like jigsaw puzzle. Everyone understands jigsaw puzzle, right? So you cut the paper, you cut the picture into jigsaw puzzle like small pieces, and then you take all the pieces, put it in an envelope, put the address of the receiver, okay, and
IP
put the
address.
yeah, IP address. But suppose he or she doesn't know what the IP address is. Let's say
Okay,
physical
okay.
address तो सबको पता है, ठीक है? And
हाँ,
now you want to send it, but when you try sending the whole letter, the let's say courier person says, no, this letter is too big. Okay, this letter is too heavy. I can't take it. So then what you do? You basically create like 5 or 6 different envelopes. You put some amount of pictures. Okay, in one envelope, some amount of picture in another. Means you have already shredded and cut each piece, right? So you put some picture, some shredded picture in one and another and another and another. And after that, as you do that, what you do, you basically then send those many envelopes. Okay, those many envelopes through the courier. Okay, and how's the person who will receive it? He will receive it in another manner, right? He might receive the first one later. He might receive the third envelope first, the second envelope fifth. Okay, so then you also say that this is my first envelope, this is my second envelope, this is my third envelope, this is my fourth envelope. Means what? You are indexing your envelopes as well. Okay, and also what you do, you write the address of the receiver, and suppose the courier is not a trusted courier. Okay, he wants to
so who
like
is
kind.
that courier in terms of networking?
Okay, I'm going there. I must understand the different segments. Okay, so I'm going. What happens that courier is not that much trusted. So you also need to write your sender's address so that suppose you send 5 envelopes, but the receiver, your girlfriend or whatever it is, or someone who is sending the letter receives just like 4 letters. Then he can again write a letter back to me that I have received only 4 envelopes instead of 5. Then you check, and also he will say, I haven't received the third envelope. So then you just do one thing, you just again produce another third envelope and you give it to them. Now he receives the third envelope. Okay. So this was what we call as uh, like both you understand the concept of encryption there by cutting the picture into many pieces. Okay. Partitioning, data packaging, data packet co segmentation. Okay. That was the concept of building up different envelopes. And then what you do additional information attachment, which is the sender's address and the receiver's address, and also the index of the data packet. Okay, these all concepts were explained in this small team. Now, who is the courier? That's a very good question. The courier is someone who speaks your language, and the courier is someone who speaks the receiver's address. That means he can read, like at least read the address on the envelope. He cannot open the envelope. He is only just a medium. Now, there is one more thing that you need to understand. That
ওটা end-to-end encryption তুমি বলছো।
yes, end-to-end encryption, and which is basically what happens. Do I have it? Like, give me a second. Mm, yeah, I just explained this packet switching, encapsulation, and routers. Okay, so but I think I don't have one more thing, which should have been. Oh no, I have it. Yeah, this thing. This is called man in the middle attack. Okay, so this is a concept that I want to understand through this. I want you to understand through this explanation that what happens that courier is not that trustful. Okay, what happens? Someone comes and just holds the courier like with his one hand, takes the envelope, opens it up, reads all the messages or all the pictures, and then he packages the envelope back to the person, and then he just lets the courier go. So what happened that someone in the middle intercepted your message and read all the messages. Okay, because he has the power of opening the envelope. And even as he opens the envelope, what happens? All the pictures are in scattered format, right? They are scattered totally. Now he read the indexing. So even though the pictures are scattered, he was able to rearrange the picture, right? He was able to see the picture. Now, how should we handle this? The best way to handle is to have the sender receive the key first, or receive the key at some point. Okay, or there are different ways of sending the key. Like key will, like you will do a indexing in a way, like you will say that okay, uh, capital A means the first message, small a means the second message, capital B means the third message, small b means the fourth message. But this is the concept of indexing that you have given. And this concept only exists between you and the receiver. No one else knows this concept. So when the man in the middle will take the message, he will see the indexing is so messed up he can't read it. So he can't rearrange the picture. Was able to make you understand the concept man in the middle.
হুম।
So that kind of indexing is known only by you two people. So that is the concept of encryption. Okay. Chalaya?
Okay.
Okay. Now,
বাট সব ডেটা গুলো যে যায় এগুলো সব ইএম ওয়েভস দিয়ে যায়, তাই তো?
yeah, EM wave stage eye, and how those wave transition works is basically you will see something in your class 12 called frequency modulation, amplitude modulation, packet sending, message sending. Okay. And we can go into the
ওটা
physical
ফিজিক্সে আছে
aspect.
নাকি?
Physics actually. It will be there in your physics last chapter. Don't worry. Chapter 12 or something. I forgot.
চ্যাপ্টারই
Uh,
ওয়েভস। ক্লাস
uh,
11 এর লাস্ট চ্যাপ্টারই ওয়েভস।
last chapter. Okay. Okay, whatever.
ক্লাস
We
12
were
লাস্ট চ্যাপ্টার,
discussing.
ওকে।
Yeah, we were discussing the OSI model, but currently it's already 7. Do we have time to discuss the OSI model right now?
আমার
What
কিছু
about you?
মনে নেই।
I need feedback from both of you. Can you just tell me?
নো প্রবলেম।
I don't have any problem.
Okay, so we we shall not go in depth for the OSI model right now, but let's just understand each and every layer. Okay. Uh, so let's see. Let's see a very beautiful diagram so that we can like also that would be eye pleasing and something that will be more educational as well. Okay, so these are the 7 layers of the OSI model. Okay, now as you can see there are like we can segment out the OSI model into 3 different layers as well. That is the hardware layer, one is called the heart of OSI, and the other is the software layer. So how all these are working? The hardware layer basically is the layer which interacts with your architecture or your, let's say, hard disk or your SSD or your Wi-Fi card, maybe your RAM. Okay, all the or even your loopback devices. I know I have tested the loopback devices till now. Understand there are some devices. Okay, yeah, it's difficult to say something which I haven't. Yeah, so then this is the heart of the OSI model because this is the reason behind the model being so successful and widely adopted. Okay, like that's why they're but yeah. Next is the software layer, which is implemented by your firmware, by your operating system, by basically anyone on the network, okay, having the protocols and everything. Let's go layer by layer, but what we are going to do, we are not going to start from the physical layer. Let's start from the application layer, okay, because that's the first thing the user will see, a user interface, okay. A user interface, let's say your WhatsApp. So in your WhatsApp, what happens? You send a message, right? You will see that in your application layer, you have buttons, you have everything. So like you can write text, you can send documents. That's your application layer, okay. Next is the presentation layer. And okay, a very important thing, presentation layer is responsible for your encryption and decryption, or compression and decompression of data. Okay, and all the encryption algorithms. Understand there are encryption algorithms like SH, that is your secure hashing algorithm. 256. 256 is probably what we call as SAR2. Okay, so this is the encryption algorithm. Uh, some questions like this may come, um, is in which layer? Is in which layer of OSI model? Okay. Oh, there are this is a network scan question, but yeah, algorithm characteristic, whatever. So basically, it is this encryption always happens in your presentation layer. Okay, and this is a software stuff that happens. I want to say one thing. Sometimes, okay, it will be too much in the encryption, so let's not go into that. Next is the session layer. So what is the work of the session layer? It establishes uh, connection, not connection. Sorry, so, it basically mm, okay. Let me say this. Suppose I go to my terminal. Okay. Now this is my terminal, right? This is my terminal, and suppose I want to communicate with uh, something like a window. Okay, I can open a window like my tuner window. Okay, so this is a file manager. So somehow my terminal communicated with the file manager, right? It ran a command, it communicated with it. So there also is a server, like this kind of protocol is similar to what the session layer is doing. And suppose I want to terminate my terminate my file manager, that I can also do. I can just show you again. So suppose if I do tuner, okay, this is my file manager here. Now I want to terminate the file manager from my terminal. I can do that. I just terminated my file manager from my terminal, and that is something which is very similar to what is happening here in the session layer. It can manage its sessions. What do you mean by sessions? Means this is currently we are having a class session, right? Our class session on networking. So I can terminate it. I can stop the class. This is what session layer is doing. It can manage the session. It also starts the session. It also okay. What it does it बोल रहा है letter there is 1 2 3 4 indexing. It also matches the indexes. Okay. Niket, please mute your microphone. Air noise is coming. Now after that we are going into the oh okay. So next we have the transport layer. What the transport layer does, it's the main thing. It implements the TCP and UDP protocols. Okay, what is a TCP protocol or UDP protocol? Okay, always forget that UDP is it uniform or universal. Okay, let me take a guess. Okay, this one it should be no, it was not. Oh, what was the uniform for example? That is a user. It is yeah, I think it is the user datagram protocol. I think or that uniform datagram. It was what user. I think user. I forget that. Okay, I forgot the full form. Nice. UDP. User datagram. Okay. So this is the protocol that is basically used as like to send messages, transfer as datagrams in packets. Okay, what do you mean by datagrams? That might be a question to you, right? So this is a datagram. Like I want a picture. I want a picture of a datagram, right? Datagram illustration. I want those rectangular pictures. Just a second. Do I have a good picture? Yeah, this is kind of a good picture. Let me just open it up. Okay, the picture quality is not good. Right. Okay, can you see this? Can you see this? Everything fine? Okay,
Okay.
see. So at the upper layer of the message, this is your application layer, and this is your upper layer headers. Okay, headers you just don't think about it much. Then what happens? As soon as it interacts with the TCP UDP message protocol, it gives a TCP UDP header. What do you mean by a like TCP UDP header? It basically attaches to your message. It gives extra information to your message. Okay, and what that extra information basically does is your um, what do you call this? Like this is the transmission control protocol. This basically adds that address that we no, not that address, because that will be added in your IP header. But how do I describe this? No, there are MAC addresses and there are. Wait, this is not exactly a good diagram. Give me a second. Let me find a good diagram. I want the two different things to be there. If I have it, there should have been with picture. No. Mm, are there good pictures?
মাইক্রোফোন ঠিক আছে?
Hello? Yeah, am I audible?
না না না, আমার মাইক্রোফোন ঠিক আছে, আমি হেডফোন
হ্যাঁ
লাগিয়েছি
হ্যাঁ,
তাই বললাম।
তোর ঠিক আছে. Just give me a second. I'm trying to get a note. Wait, let me just go here. I want the breakdown of the TCP header file. Yeah, this is it. This is what I was looking for. Yeah, good enough. Yes. So this is the TCP header. Okay. Remember that addressing that we were talking about. So here it needs to understand that you need to understand like this IP address, the IP datagram. This basically is the address. Okay. This is the address. Like suppose it's your apartment address. Okay. Like suppose you live in a huge apartment. It may be let's say 36 stories apartment. Okay, and you live on the 24th floor. 24th floor. Okay, and the TCP UDP basically attaches the address of exactly your room. Okay, and IP datagram attaches the address of the apartment. Means it gives a way more broader perspective. Now here is the source for मतलब कहाँ पे जाना है exactly तुम्हारे रूम में आके तुमको मैसेज डिलीवर करके देना है ठीक है it's that kind of thing. Now understand that there are this sequence number and acknowledgement. This acknowledgement number, there is a huge story on this acknowledgement number. Okay, basically this handshaking that happens in this header. A simple handshake example would be, suppose I send a message. Okay, this is a paradox. It's a very common problem that I want you to understand. Suppose I send you a message. Okay, but suppose there is a possibility that the message can get lost. Okay, so if it gets lost, what happens? I need to resend it. So how do I know that whether the message is getting lost or not? The best way is to have you respond to me that brother, I did not get your message. Okay, so what to do. Then unless and until you get that message, you are not sure that whether the message got transmitted or not. He can say that I have received your message. But suppose first you what needs to happen? First, you need to establish a connection that hey, I want to send you a message. Can I? Then your brother from other side says yes, yes, you can. I'm free. Then you send your message. But suppose the first message gets deleted, then you can see that after 5 milliseconds or after some seconds, you never get a response. So you again send that brother, can I send you a message? Then you get a response, yes, you can. Then you send a message back. Okay. Then he says that okay, I have not received the message or I have received the message. Okay. Then you send the message again. Okay. But now this kind of forward and backward can go on and on. Okay. Until and unless they both receive, they confirm that they have received the message. But this kind of acknowledgement could be happen by a simple true and false. What happens? Suppose in between the communication, some this true and false value gets flipped. Means suppose in the last acknowledgement that he says that he has not received the message, uh, he basically says, he said that he has received the message and it converts into he has not received the message. So in that flip of the bit, you again send the data. This overrides the data. Then you then you get like somewhere else a lossy compression or lossy transmission. But this kind of things can happen. This is a paradox. Okay, there are solutions to this, but I just wanted to say the paradox here. Okay, fine. There is one more important thing, that is the checksum. This checksum is actually a hash. What is a hash? Hash is a particular unique number or let's say string that is dedicated to this message. Okay. Understand that each and every hash for each and every message will be unique. If by chance two hashes match, means there is a collision. That means there is some chance, there is a probability that the message or the network got what they call this hacked or compromised. Okay, the network got compromised. So that's why you have this checksum. Finally, you have this layer 2 and layer 1, which are basically the like more lower levels of the data link layer and other things. Okay. After the transport layer, you have the network layer. This basically moves the packets from the source to the destination, and they are basically the couriers. Okay. And finally, you have the data link layer, means this actually rearranges the data. Like basically, okay, ये वाला मेरा IP एड्रेस है, ये वाला मेरा TCP है, ये काम का नहीं है, मैसेज कहाँ पे है, ये मैसेज को लेता है, फिर जो है अपने फिजिकल लेयर में वो मैसेज दे देता है. इट जस्ट गिव्स द मैसेज डायरेक्टली टू द फिजिकल लेयर, एंड द फिजिकल लेयर देन कैन एक्चुअली अनरैप द मैसेज ऑन द मैसेज already unwrapped. It will just directly show the message or maybe store the message or whatever it wants to do. Okay, so was that clear? Yeah,
এত প্রসেস করতে কতক্ষণ সময় লাগে?
it happens in what 26 milliseconds, 90 milliseconds, 100 milliseconds. Yeah, it's that fast.
ওকে,
Okay.
আর ওএসআই কি আমাদের আছে?
The whole OSA model you have, and generally sometimes the question comes like write the function of this OSI layer or this model, this layer. Basically, you need to understand the functioning of each layer. Okay. Then we okay, today it's already over time. The TCP/IP model implementation and all this we will do in the like upcoming classes. Okay. This is the whole syllabus that you
স্যার
have by the way.
মাথার পুরো মাথা 6 ফুট উপর দিয়ে বেরিয়ে যাবে ব্যাস।
Okay. Jyotika, did you enjoy this class? It was maybe it was a bit advanced, but what's your feedback on this?
In class 12, will you repeat all this?
In the next class, will I be repeating? If you want, I can.
No, in class 12.
Oh, okay, in next class, of course. Oh, in class 12. Okay. Of course, I shall be repeating. It's not like I'm just saying that you can join this class. This was basically for Niket. Okay. But I wanted you to just have a look out on what's there to come in your class 12. Okay.
Okay.
Okay. Of course, I shall be repeating this again in 12, so don't worry about it. And if you are still like what do you call this? A student of mine, then of course depends. Now it's done. Any questions, Niket? Especially any questions? Till now.
কি কোয়েশ্চেন করি তুমি আমায় বলো।
You have asked a good question on this TCP model. I shall try to answer that question. Like basically, how those IP addresses are getting assigned. So the dynamic hosting thing. I just when I was in your age, I just okay. It dynamically assigns the
কত?
address,
আচ্ছা
but I never got into
সিমাসে কত
it.
ইয়ারে বল?
Um, Currently how many years? It's like 5 years. Yeah.
18 আমার, তোমার?
Oh, there
মানে
is
18
4
হবে
years.
রিসেন্ট।
4 years. 4 years.
আর তোমার তোমার কবে বার্থডে, এই ইয়ারে তোমার বার্থডে কে হয়ে গেছে?
Bro, it is currently streaming. So since we are okay, I'm going to close the stream. Then we can
স্ট্রিম অফ
discuss about that stuff. Okay. It's
স্ট্রিম অফ করো।
yeah, streaming has to be now turned off. Oh, guy, you also learned how to like stream your own YouTube videos, right? That's also something
হ্যাঁ,
that you just
স্ট্রিম
learned.
অফ করেছো তো?
Yeah, yeah.
আচ্ছা,
So we are just now
ঠিক
closing
আছে।
the stream. It was a 2-hour stream. Let's end it.
হুম, আচ্ছা ঠিক আছে।
Yeah.